So as we complete review of content for Module 1 this week, and you engage remaining assignments, your solution is essentially to respond to an email invitation at your UVI email account from Cisco, the Net Academy. You should have received something that asks you to respond, and that confirms your access as an enrolled student in the Cisco Net Academy. It also provides you with access to install Packet Tracer, and that's something that is due 11 a.m. Monday, 23 January. So essentially, there were two other assignments that were posted. They're both, the last one was due, the first one was due Saturday this last week, but if you haven't yet completed that, you can still submit. So, and that's an option for additional credit to provide proof of rental or purchase of the legitimate textbook, legitimate copy of the textbook. The article review is pretty much like your article review last semester, except it's greatly simplified. There's some basic elements. It needs to be an article about networking. It needs to be done in proper English. There need to be 2 paragraphs, and there needs to be a title and a reference, top and bottom. Each of those elements constitute 1/2 of a point. So essentially, we just want you to identify something of interest in networking that you can review and then summarize, right? And there is a sample that's provided here. So this last posting for the solution, if you have not yet received the email notification or invitation from the Cisco Net Academy in your UVI inbox, it would be really good if you were to send me an email that says, hey, I don't see anything like that. And it's important to use your UVI email, not your personal email. Once again, if you send me something from your personal email and you're looking in your personal email inbox, it's not going to be in there. It's going to be in the UVI. Your membership as you're a member of the student body at the University of the Virgin Islands, and by extension, your access to Net Academy, right, is a function of your enrollment in the class. So you have to work that through the UVI email. And I just want to understand, I want everybody to understand we don't need to chase ghosts needlessly. Send email to me using your UVI email account. That way I know you can still access your UVI email account, and you're in the right pond, fishing in the right pond. Okay. So I will post a rubric that shows what you have to do to post each point, right? To log each point. And the first one is you have to show that you've responded to the invitation or the notification that you are now enrolled in the Net Academy. That's the first step of this solution. So it would be good if each of you could check that along the way. That would be a good thing. Any questions about the first steps to set the stage for our solution? Okay, hearing none. Can somebody verify that you can still hear and you're still with us?
Yeah.
Yes.
Okay, great. Thank you. So in our last class, we were working through the student learning objectives, and we called out a distinction between the terms syntax and semantics. So if you look, this is one of our defined objectives for, I'm trying to figure out which one. There's something explicit in the terms and concepts, right? Including but not limited to. If I don't have, I think I might revise this study guide and add syntax and semantics to the end of this list right here, just to make sure it's explicitly listed. But the but not limited to is kind of a catch-all. So now we did mention the difference between circuit switched and packet switched networks in our last session. And now what we'll do today is to describe the 5 key aspects of networking, including the basic function or purpose of each aspect, and then provide the names and essential details for each layer of internet and OSI models. So without further ado, one of the things to understand about networking is that it's a bit like Shrek. Does everybody remember the reference to Shrek?
Yeah.
So ogres have layers in the first Shrek movie. He's explaining to Donkey that ogres have layers, and we have a physical layer. So in the 5 key aspects of networking are concepts that parallel each of the layers and the different protocols that operate at each layer. And by the way, I think we mentioned the word stack. So if you have these layers and you have separate protocols for each of the requirements at those different levels, the collection of protocols is called a protocol suite, or it's often referred to as a stack. So when we talk about the network stack, we're talking about all the different layers and the related protocols. That's a term that's commonly used. We say, hey, have you checked the network stack? That means, have you looked at the physical layer to see if the signal, is there a basic problem with the physical layer? In fact, Comer plainly describes the first layer, level 1, as signal over wire, right? So in terms of the 5 key aspects of networking, the data communications piece is signals over media. And traditionally, the only media we had to work with was wire. And then straddled on top of that are ones and zeros that are embedded in the signals. So bits over signal, that's layer 1. Right? Any questions about our first key aspect of networking? Now, greetings, Elijah. How are you? Are you there, Elijah? Yes, no, maybe? Okay. One of the things that I want to call out to you is that Comer has a very academic or traditional and theoretical view of the 5 key aspects of networking, and they are explained and described in slightly different terms than how they're presented in your study guide. I have taken the artistic liberty to kind of revise how these are explained, because I've been working with networking in a professional capacity in industry as a certified systems engineer with Microsoft for about 25 years now. So in the world of work, you have 2 domains or 2 groups of interest. You have the academic engineering crowd who tend to look at the theory and the concepts, and then you have industry that are the engineering side of things that actually apply those principles and make them work. Sometimes there are differences between industry standards and formal research and academic standards. We're going to talk more about that in a minute, but there are two primary models that we use to reflect each. So the industry standard is a little simplified. The academic and research side of networking, the cutting edge side, it has more layers or more aspects to the way they define how a network stack is managed. So first layer is physical. The important thing to remember is that the first layer is physical, and this is where you get the signals over the wire, and embedded in the signals are bits. The second aspect of networking has to do with the local network or broadcast domain. So the term broadcast domain is often synonymous with local area network. Now you can stitch, and you'll see how, with virtual networking, so VLANs, it's called virtual LANs, you can kind of extend the broadcast domain using some magic and protocols at a different layer so that you can have separate, isolated, private, internal, non-routable local networks beyond physical boundaries. So we'll get into more detail about that in a later on in the course. But the important thing here to remember is that we go from an individual device or system in layer one, and then when we get to the second aspect of networking, now we're talking about a collection of two or more devices on a network, and it's a local network, typically a private internal non-routable network, and we'll explain more what that means. And oftentimes the term broadcast domain is used to express or describe the same thing. The word broadcast is intentional. Broadcast, did we or did we not in one of our previous classes relate that Wi-Fi is radio?
Yeah.
Yeah, so we explained that broadcast is, that Wi-Fi signal is basically radio signal. How many of you knew that the most common standard of Wi-Fi is actually the same microwave that you use in the kitchen to heat like a baked potato?
Yeah, that's why if you have your router next to it, it might interfere with it.
Yeah, if you have an older, it's kind of a funny thing, but not a funny thing because of what it implies. And this is kind of a health and safety thing that I'd like to share with you, because anytime we can talk about health and safety in the context of a professional career path, that's important to mention. If you work a lot with Wi-Fi and you notice that every time somebody's using the microwave in your kitchen, your Wi-Fi bandwidth, your performance drops. What's happening is that you have a faulty microwave in the kitchen, and it's releasing that energy, it's radiating that energy in the near environment, and that's jamming the signal of your Wi-Fi router. I don't know how many of you would be interested in subjecting your own body tissue to microwave energy that's not where it's supposed to be, but this is a matter of research and debate for many years now about the safety of cellular service and the safety of Wi-Fi service, and how proximity is an interest. It's significant to mention that signal strength is an inverse square function. Now, what does that mean? If you cut the distance in half between a source of radio or a source of microwave or a source of radiation, and you cut electromagnetic radiation, and you cut the distance in half, the intensity of that signal increases by a factor of 4. So 1/2 squared is 1/4, and then you flip it. So it's 1/4 inverted is 4. So it's 4 times the strength. By the way, this is also true of sound energy, which is a different kind of wave in physical terms. if you look at the physics of this, sound energy and electromagnetic light and radio energy, there's a lot of parallels between how waves travel and how they propagate and how their intensity changes with over distance, right? A lot of it depends on the media through which that wave propagates. So sometimes sound waves are going through air, sometimes they're going through water, right? Sometimes radio or light is going through glass, like fiber optics. In other cases, it's going through air, like a Wi-Fi signal. But in any case, the term broadcast is intentional here because whether you realize it or not, a wire, networking over wire also includes broadcast. So the signal that's pushed out onto the wire is a broadcast transmission, and anyone on the wire can hear it. Anyone on the wire can receive it. And that's an aspect of networking early on that caused huge problems with security. Okay? Because people thought, well, I have a wired connection, I'm not worried about, oh yeah, you should be. If you have an Ethernet connection with a Cat5 cable and a wire, that doesn't mean that what you're putting out there isn't received by everybody else on the local network. When you're connected on a network, whether it's wire or Wi-Fi, you're broadcasting your packets, and anyone else on that network, if they're configured incorrectly, they can look at what you got. They can get into your Kool-Aid without too much trouble. This is just like a value added mention to our review of this topic. We'll get into more of that later. But the second key aspect of networking involves broadcast. And what's really important to understand is that when you get to a local area network, the ones and zeros, the bits, are packaged or bundled into a unit called a frame, a component that's referred to as a frame, a wireless frame, a Wi-Fi frame, or an Ethernet frame. So whenever you hear the term frame, you're talking about the local network. It's the link layer. It's layer 2 in the protocol stack. And we'll see what that means more in a minute. Any questions about the second aspect once we connect 2 or more systems with that media? So this is before there are other systems involved. It's just the network interface to a given media and a single system or device. And then as soon as we get to the second aspect, now it's 2 or more. Everybody with me?
Yes.
Okay. Now, we use an internet, and you can connect networks to networks. These are called internetworks. And when you get to the point where it's global in scale, the term internet is typically the term that's used. But internet, as we've already discussed, can also be used to talk about a network of networks, not necessarily the global internet. As soon as that happens, you have to have a way to route traffic that belongs on the one local network and traffic that has to go to the next connected local network. In other words, there's traffic that the network knows, oh, this is local. So this broadcast, it should stay here. And there's a device called a network router that inspects each packet, because we take the frame and inside the frame, we create another bundle or container of ones and zeros, bits, right? And we call that a packet. The packet identifies whether something is local or if it goes outside to the wide area network or metropolitan area network. Now, a wide area network would be 2 or more local networks connected. A metropolitan area network would be 2 or more networks in the same geographical location, like city, a metropolitan area, a university campus, a corporate headquarters where you have multiple buildings, multiple domains and all that, broadcast domains and so on. So the important thing to understand about the third aspect of networking is that there has to be some method to route traffic that belongs outside the local network so it can pass it on to another network, right? That's really what happens. We have all these local networks that are all stitched together, and the router says, oh, this goes outside this local network, and it routes that packet of data onto the next network. That's what routers do. Any questions about layers 3 and 4? By the way, this is where the internet protocol comes into play. If you've heard of IP network addresses, it's the third key aspect of networking, and layers 3 and 4, where IP packets, they're encapsulated or bundled inside the frame. The frame operates on the wire in the local network. So there's a very important distinction between layer 2, which operates locally on a network. It does not require a network address whatsoever. A lot of people don't understand that. They're like, well, how did I get hacked? We're not issuing network addresses. How did that happen? Well, there's an association between a MAC address. We'll explain MAC addresses in a minute. And the network address for a routed network. Any questions about the third key aspect of networking? The fourth important aspect of networking has to do with the applications that we love and use all the time. Okay, what am I talking about? We're using it right now. We're using web pages, a web application called Blackboard to share details about this course. So HTTP is a protocol. It's a service that helps work the network applications that are using that protocol. Whenever you deal with the software, the programming, the applications, you're dealing with another container of ones and zeros. At this level, the packet is opened up and unpacked, and inside is a unit of ones and zeros, a bundle of ones and zeros that are referred to as a datagram. So when you hear the word datagram, you're operating above layer 4 on the network protocol. You're dealing with either layers 5 with the internet model, or you're dealing with 5 through 7 in the OSI model, and we'll talk about those two models in just a minute. The last aspect of networking has to do with the management, okay? You have to control the network infrastructure, the equipment, the routers, the switches, the Wi-Fi access points, right? Sometimes you have Wi-Fi access points that don't have a router function. What am I saying? You have a Wi-Fi hub that extends the Wi-Fi network, but it doesn't do any of the routing. It doesn't have a router built in. Those are called access points, wireless access points, or WAPs. Many WAPs are designed without a route function. And that means that they're basically just a way to repeat the wireless cover. In any case, you have to be able to control those WAPs. You have to be able to configure those things, the switches, the hubs, all of the network infrastructure, the bridges and routers, all of that. That has to do with the last aspect of networking. So those are the 5 key aspects. Now, there is more explicit information about each of these 5 key aspects in the detail that follows the walkthrough we just did on these 5 points. I encourage you to read this separately, okay? Just remember, when we talk about frames, we're on layer 2. If we talk about packets, we're on layers 3 and 4. That's what the L means. L means layer. So that's an abbreviation. Whenever you see L, That's a short abbreviation for the term layer. Now, there is a special address that is permanent on each networked device. Whenever the device or system connects to a physical network, there is an interface of one type or another. In some cases, it's a wired connection. In the case of a wireless, it is a Wi-Fi radio interface that exchanges data packets to connect to a Wi-Fi network. That interface is on layer 2, and each of those interfaces have a fingerprint, an identity. And I like calling this the MAC identity instead of a MAC address. That's just my own personal preference. You'll see a lot of references in industry and informal references like Comer, where they talk about the MAC address. But you're going to soon find out that addresses can change depending on the context of the network. And the MAC, the media access control value, is like a fingerprint. It identifies the network interface and that device on the network, on the local network. Without that essential identification, you can't get anywhere. And one thing that's really important to understand is that MAC addresses are supposed to be unique. There can never be two MAC addresses of the same value for any network device on the entire planet. And hackers understand this, and they intentionally duplicate the address. It's called MAC address spoofing. They find out your address, they want to get your junk. They're on the same media. They set up their own interface with the same identity, and that interface says, oh, I'm that person, and their interface picks up all of the traffic that's intended for that other person. It's called MAC address spoofing. In general, you can find the MAC address of an interface in simple terms just by referencing the network details with a simple command from the command prompt. Can everybody see my screen?
Yes.
Yeah. Okay, so there is a specific command that shows the MAC address or the MAC access control address, right? And again, I like to use the term identity because that provides a specific mindset that's more keyed toward network security that's really important. So just remember that MAC addresses are really like a fingerprint. No two are alike in the world. IP network addresses can be reused over and over again, but they can't be duplicated on the same local network either. We'll talk more about that in a minute. When you run the command prompt as an administrator, you'll notice in the upper left corner it says administrator. In order to execute the command you need to identify the MAC address on your network interfaces, you need to have a command prompt that's opened with an administrative prompt. In Linux, you're going to run, you may, depending on the flavor of Linux, you might have to be root in the terminal. For those of you that are familiar with Linux, you can just smile and nod. For those of you that don't know Linux, we can demonstrate that otherwise. The commands are almost the same. And by the way, a lot of Linux commands work identically on a Mac platform because Macs are kind of a flavor of Linux. And I don't want to start an argument with people who are Apple aficionados because they would quickly argue that they're not like Linux, they're more like Unix. Yeah, okay, so that's something we debate in the operating systems course. The command that you're interested in doing, and I'm going to do this a little larger, so I'm going to open the properties of my, I'm going to demonstrate this several times during our course. You can change the font of your prompt, your command prompt, and your window so that basically it's larger and easier to read. And you can change the colors of the screen text so that it's something like this, stands out a little more. That's easier to see, right? Everybody see what I did there?
Yeah.
Okay. Well, I'm going to ask you to do the same when you're capturing screens to demonstrate that you've accomplished a network task. You're going to issue the command ipconfig with a space, and then you'll have a /all. When you hit enter, a whole bunch of stuff or junk will show up on the screen, including the MAC address for given interfaces. And what you see here is a whole series of interfaces. I have an Ethernet port on my laptop. That means I can connect a Cat5 cable to Ethernet and connect my laptop. This physical address is the MAC address, and it is expressed in hexadecimal characters. Now we're going to learn about binary and hexadecimal in later modules of the course, and I will teach you the mathematics you need to know to function with hex or hexadecimal values, right? So you'll see in hex values the letters A through F. This is a 48-bit. So the physical address or MAC, media access control address, is composed of 48 bits, which means when I look at what this can do, if I take values for 48 sets of ones and zeros, I need the scientific calculator. Everybody see what I'm doing here?
Yeah.
So I'm going to use 2, and I'm going to use the y to the x function. So the x in this button is actually the 2 I just entered. And then I'm going to put 48 in here because there are 48 bits. How many unique identities can currently be created with the 48-bit MAC address range defined by the Internet Engineering Task Force and the IEEE? Those are international professionals and engineers. Well, at least 976 million. Oh, wait, 474 billion. 281 trillion 474 billion 976 million 710,656. There is no reason why any connected device on our planet cannot possess a unique media access control address or identity, right? Now that's just the wired connection. The wireless adapter here on my laptop, if I go further down, this is the one that actually received a Wi-Fi connection to connect with you today. And this is my, so you have 6 pairs of values, 1, 2, 3, 4, 5, 6. 6 pairs of hexadecimal values, and 0 through 9 for numbers, and A through F for characters. That's how hexadecimal works. Physical address of my Wi-Fi adapter that's being used right now in this session is this right here. And of course, it tells you what kind of Wi-Fi adapter I have. We'll talk about Wi-Fi standards and how Wi-Fi 6 and AX is, ooh, that's so cool. But not if your Wi-Fi routers don't have AX standards built in. On the third layer, I have a network address. On layer 3, I have a network address, and it is a private internal address of 192.168.1.4. In my home network, there is no other device that may possess 192.168.1.4. If someone else manually assigns an IP address of 192.168.1.4 while this is being used, the network crashes. Don't do this at home, kids. I'm just saying, these are some aspects of networking that we need to be very clear about. No two IP address numbers on a given local network may be duplicated either. So this can't be duplicated worldwide because it's a unique identity. But on each local network, you have temporary numbers that identify the device that's connected, and those numbers help the router function. So a router cannot work without a network address, a local network address based on the IP protocol. Okay. Once again, if this is Greek to you, don't sweat it. We'll be talking more about this and explain all of this soon. Here is an example of an application level criteria or detail. We use DNS all the time when we're on the internet. We use names to use email and web, to navigate the web and to use email. We don't send email to 206.53.27.105. We can't keep track of all the network numbers, especially when they change every time someone connects to a network. And yes, these often change, right? But DNS is something we'll be talking about quite a bit. It's what makes the internet work, and it's on the application layer. So those layers are actually very important ideas. Any questions before we clear this section here and go on to sections F? These are student learning objectives F and G. No questions. Okay. Is everybody still there? Or am I talking to myself because my network died?
We're here.
No, we're here.
Okay. Now, a network address is actually just one half of a network number. When it's assigned, when you connect to a network, a layer 3 address, a network address, is assigned either manually or automatically. You can do this physically yourself and manually assign a network address, or in most cases, it's automatically assigned by a special service that's run by a special server, and it's always embedded inside the network equipment. It's called DHCP, Dynamic Host Control Protocol. When you connect to a network, the DHCP service assists with the automatic assignment of network addresses so that no two are used. No two identical numbers are assigned to two different devices. So every time something connects, the DHCP server goes, no, we can't use 4 on this because Tim is already using it. Professor Kentop is already using .4. So the next device that connects, like if I connect my phone right now, the DHCP server that's running inside my wireless router would say, okay, 4 is already taken. Let's give .5, as in 192.168.1.5, to the smartphone that's trying to use the Wi-Fi right now, right? So automatic network address assignment is a function of the service we call DHCP. And once that happens, an IP address, really, that number is only part of it. The subnet mask, this is a component of the network address. A proper network address has to include a component called a subnet mask. When you look at this here, what you see is the first half of a network address, a proper network address. But a proper network address cannot be fully determined unless a subnet mask value is also provided. Now you're going to look at these numbers 255, 255, 255, and 0. And what we're going to explore in class on Friday is how this mask lets the equipment, the network equipment, determine, okay, where's the network number here and what's the local host address on the network. So what are we saying? you mail things all the time using the US Post Office to a given zip code. Everybody with me?
Yeah.
So the zip code is like a network identity. If you're sending mail to a zip code, you're sending a parcel or an envelope using the mail service to a given neighborhood based on the zip code. We would call that the neighborhood identity. And the street address on that envelope or box or parcel is the rest of the address. It's like, okay, once I get to Charlotte Amalie, once I get to Frederickstead, if I go to this street and this building and this suite number, now I've delivered the rest of the package based on the host identity. So part of the network address belongs to the host, part of it identifies the neighborhood or network. We're going to talk about that more in detail on Friday, and we're going to take a deep dive about subnet mask so that you know what a subnet mask is and how it works and how it can be manipulated to great advantage to help maintain your network, to troubleshoot, and to hack a network. Hackers use the subnet mask in a very devastating way. So stay tuned. Join us on Friday. So today we touched on student learning objectives F and G and started to explore the components that are used to create a proper network address. After we reviewed the important aspects, the 5 key aspects of networking and the different layers, we'll get into models after we review the subnet mask on Friday. Any questions before we close out today? Okay, I'm going to stop recording.